Hello students, today we are going to see one more problem related to Turing machine. Okay. So the problem is designing Turing machine for a set of strings formed by 0 or 1 in any combination, okay. And the condition given is substring should be 3 zeros. That means whether they give in the question or not, we have to take the minimum string as 3 zeros, okay, and maximum you can extend it, okay. So here we have to analyze that the language which is given to us is 0 plus 1 star followed by substring 0 0 0 which is given as a condition, and 0 plus 1 star, okay. Star indicates that the string before these 3 zeros can be present and cannot be present before and after, okay, and plus indicates you can take 0 or 1 in any combination, okay. So before and after the substring you can have any one of this combination. Since the minimum string length is 0 0 here, we will start with the minimum string length for the design of Turing machine. This is similar to the finite automata diagram. In finite automata also we will always start to design the strings with the minimum string length, and then when we go on adding the strings one by one. So minimum is 3 zeros. Simply draw the finite automata diagram, Q0, Q1, Q2, Q3, okay. Drawing this Turing machine is simple, okay. Take 3 states, okay. Take 4 threads to accommodate the 3 inputs. So this is a minimum string length 0 0 0. That is what we have done in finite automata diagram. After this, now we are going to convert this in terms of the Turing machine. How to convert this? Just draw a vertical line. That means we have been given a string length which is of infinite finite type, 3 zeros are there. After this we have blanks before these inputs and after this input, okay. So just draw a vertical line which indicates that the input is read, okay, and it is read after reading the input. It is kept as 0 only, it is not being replaced with any other letter, so it is 0 only. Then after reading this, the finite control will go to the next symbol, okay, which is towards the right side of this, okay. So it is the right side, we have to indicate the direction here compulsory in the Turing machine. Then second 0 is read and it is read as 0 only, it is not changed. Then we go to the next direction, next input using the right direction, so we write it as R. Similarly third 0 is read and it is kept as 0 only, so after write a vertical slash which indicates it is an indication of the difference between input and output. Write it as 0 and it goes towards the next symbol using again right direction, so comma R we write. After this finite control reads blank, it indicates whenever blank is found, it indicates that the input is completed. So whenever input is completed, Turing machine will not halt at the blank symbol, it will halt at the last symbol of the input. So last symbol is 0, so it moves towards the last symbol and it moves towards the left side of the input tape to get the last symbol, and then it will stop, okay. So after Q3 we have it is read blank and the blank is kept as blank only, and then it moves towards the left side, okay. And halting means final state, it has gone to the final state, which is indicated using symbol QA. QA indicates accepting state. In finite automata we call it as QF, that is final state. Here we call it as QA, okay, that is halting state. So to the existing finite automata diagram only we have made all these changes. So drawing the Turing machine is simple here, and we have two operations here, one is read operation, one is replace operation, okay. So whatever we are doing is we are reading the zeros, all the zeros as it is, even blank symbol as it is, we are not replacing it with any other symbol, okay. So these two operations we use, so most of the problems we use only read operation. Then after satisfying this minimum string, then we have to indicate the next string, okay. If the string length is increased, if something is there before the substring, if something is there after the substring, then how to accommodate those strings, okay. Now this transitions as it is I have kept, there is no changes, okay. I am just highlighting if there is any string before and after the substring. If anything is there before 0, if it is 1, then what we do, it is 1, that is something is there before this 3 zeros, 1 is there, that means after reading this one it should go to the next symbol 0, so it goes to this 0 and R. then again 3 zeros are there, it goes one by one. After this, if any symbol is there, 0 or 1, okay, if 0 is there, it reads this one, if 1 is there, it reads this and goes to the halt state until it repeats this until blank symbol is found and it halts. If suppose 0 is there, before this 3 zeros we have a 0 symbol over here, okay, after this we have blanks, then in this case substring can be this 0 and this 0 also, either it can take this first 3 zeros or this 0 or this second 3 zeros. So when first 0 is there, we don't write a loop over here, we continue with this line, okay, 0 0 0 0 0 0, one more 0 is there, this 0 we will try to repeat this over here, because it is said that it is 0 plus 1 star, so this can be present, cannot be present. So additional 0 is there, that additional 4th 0 will be accommodated over here. So in this way we will try to use this loop. The 4th 0, okay, will be executed through this transition, okay. So when we club these both things, we get the final transition diagram. Final transition diagram is your Q naught with minimum string length. This straight line indicates a minimum string length 0 0 0. When something is there between the substring, we use this 1 1, okay. If 1 is there, we will use this. If 0 is there, we will go to again through this path. After this substring 3 zeros, again something is there. If it is 1 is there, this is executed 1 slash 1 comma r. If 0 is there, 0 slash 0 comma r is executed. After the total string is completed, we go for blank symbol, okay, and blank is read as it is and it moves to the last input, okay. It comes back, it moves towards the left side like this and it halts. Whatever symbol is there before blank, whether it is 1 or 0, it moves and it stops. That indication is given using left symbol L, and then it stops, okay. And there is one more exception for this. It is said that 3 substring 0 0 0, I may get 2 zeros and I will expect one more 0 here, but in case if I get like this and again if I get 0 0 0, okay. So in such case I should not, when it is, okay, when 2 zeros are there, machine will think that it is matching the substring and it expects a third symbol as 0. If it is 1, then in that case it should not go to the next state. It should not make Turing machine to run successfully to the next state. It should make this it should make the Turing machine to move back to the previous states and again start checking for next whether there are 3 zeros or not after this one. So that is why we are using, see here, if first 0 is there, I may get like this. After first 0 also 1 may be there, after 2 zeros also 1 may be there. After first 0 if I get 1, the machine is made to move back to the previous state and again check after this one 3 zeros are there. If after 2 zeros I get 1, again I make the machine to move to the initial state and again check whether after this one 3 zeros are there, so that we can move, we can go successfully towards the accepting state, okay. So this is the final transition diagram, okay. After 3 zeros if we get 1, no problem, because already substring 0 0 is covered, so we go to the next state and we go to the blank symbol, okay. So coming to the transition moves here. So these are the transition moves, these are simple, okay. We have the present state Q naught, okay. So Q naught we are giving 0, Q naught before vertical slash whatever symbol is there, that is input. So that input we are representing here 0. After vertical slash 0 is kept as 0 only in input type, it is not changed and the direction is R. So that is indicated here 0 and R. After vertical slash whatever is there, this is what we are writing. So across each state we will check 0 and 1 and blank symbol, because there are 3 symbols we are using in all the Turing machines. We need to also check blank symbol also across each and every state. Q naught with 1 0 and blank, Q1 with 1 0 and blank, okay. So whatever is there we are writing, Q1 0 is there, that we are writing it is going to Q2 state and it is written, it is 0 only, okay, at the output, and it is changing, it is going to the next state using right direction, that we are writing over here, okay. And if it is 1, it is moving back. If it is 1, it is going to Q naught and 1 is kept as 1 only. See, after the vertical slash we have 1 only, so it is 1 over here and it is taking the right direction R. R indicates that after 1 we are going for the next input, we are finding the next input which is towards the right side of 1. R does not indicate that we are moving towards this transition, we are moving to the previous state. This R indicates only inputs, it does not indicate the state. So don't get confused here, don't think because we are going towards the previous state left side it should be L. This R or L is for inputs only, the inputs which we are taking across the input tape. Okay, across each and every input we should go towards right side only to read the next symbol. Okay, so R indicates that after reading 1 we should read the next symbol which is towards the right side of this one. Okay, so each one we are going to write as it is. So we find a blank over here only at the state Q3. So we get a Q at Q3 we get QA accepting state blank. Blank indicates end of the input, so go towards the left side of the blank which where you see the last symbol before blank. Okay, and you should also include QA, even though there are no transition in accepting state, in the transition table we should compulsory write QA accepting state, and there will not be any transitions, simply keep blanks. Okay. So this is about the second problem. Thank you.